So my name is Yale Cohen. I'm the graduate group chair in bioengineering, and I'm actually way back in the day. I was actually a student at Penn in their PhD program. So I understand both sides of the fence: how to be a student in the program and how to be a faculty member. So feel free to put questions in the chat or ask me questions as we go along. Could we go to the next slide, Christina? So what is bioengineering? So bioengineering is using engineering principles to improve human health. And that encompasses a wide variety of fields, everything from trying to understand fundamental processes in the human system, in the human body, to trying to build the next version of MRI machines. So it's everything from basic science, basic engineering, all the way up through translational and ultimately clinical applications as well. What's important to know about bioengineering is that not only are you part of the engineering school, but you're also actively involved in the School of Medicine. You're actively involved in the Children's Hospital, and you're actively involved in lots of other departments across campus. You also can be involved in the veterinary school and the dental school. So bioengineering has really a wide range of access across the whole campus. We're also the top ranked engineering department on campus. We're consistently ranked in the top 10 or the top 5. Next slide. So we have 133 graduate group faculty. So these are folks who are across the entire campus. As I said, it's in the medical school, it's in the vet school, it's in arts and sciences, so like psychology, biology, and physics. We have 150 PhD students and 90 master's students. Our typical class size is about 30 to 40 students a year. As I have alluded to, bioengineering is a very, very broad discipline. So because of that, our students and our faculty are involved in research that encompasses a wide variety of fields. So for example, our students are involved in the Center for Neuroengineering. So folks like there are using machine learning to try to detect epilepsy, or building next generation electrodes in order to detect epilepsy. So then, and perhaps using brain-computer interfaces to stop the epileptic seizure. The Center for Mechanical Biology is studying the engineering principles underlying how muscles work. Targeted therapeutics is involved in nanomedicine and nanotechnology to determine new ways to deliver drugs, to determine new ways of delivering contrast agents to improve CT, MRI, and other forms of computation. The PIC Center is a broad-based center on campus, but many of our faculty are involved in there in developing sort of computational principles to understanding drug design, understanding tumor development, and things like that. And the Epigenetics Institute is once again, it's a combination of computation, trying to model the human genome. Also, it's people are doing what work in the lab to understand how different epigenetic phenomena affect basic physiological processes. Next slide, please. As Christine alluded to, we have a master's program and a doctoral program. We only have one master's track. However, as of last week, we've developed what we call concentrations in bioengineering. So while you're not going to get you'll leave with a master's in bioengineering, you can say that you have a concentration in biomaterials, biomechanics, neuroengineering, drug delivery, or what have you. So we'll allow you to have concentrations and specializations within the program of the master's. Next slide. A lot of our students do a wide variety of things. So as Christina chatted about, there's the Penn Center for Innovation. So many of our students are involved in the Penn Center for Innovation. One of our students is actually graduating in about a month or so, and will immediately start up as CEO of his own startup based on his research. So people are very involved in device design, in microfluidics for drug delivery, Lots of folks are obviously staying in academics and doing teaching. Some of them are going to tech. We have a large biotech environment throughout the city, mostly centered around gene delivery. And so you all have heard about the mRNA vaccines that are coming on. That's a Penn discovery at fundamental. The Johnson & Johnson vaccine that was just approved today, the basis of a lot of that work was at Penn and is still at Penn. So we do a lot of work with in genetics, with gene delivery and immunotherapy. And also, as you can well imagine, a lot of our students are in the MD PhD program or in the vet PhD program and are working on becoming clinician scientists. Next slide.
I think that's the end of your presentation, but if you have anything else you'd like to share, you're welcome to. You have plenty of time.
I don't. I'll put my email in the chat so folks want to email me offline. And so I think one important thing to understand, and this is true for all PhD programs and master programs at Penn, and I think it's particularly true for bioengineering, is that graduate programs are university-wide. So for example, I'm not a faculty member in the bioengineering department. I'm actually in the medical school. I'm actually in a clinical department. So what that means is that when you're joining a graduate program at Penn, you're joining a university-wide program. And so that gives you access to a wide variety of faculty, a wide variety of programs. And so your boundaries are not the department and the 20 or so faculty members, but it's the entire university. And that's also true of mechanical engineering as well. But I think for bioengineering, because of our strong links to all the hospital systems, the vet school, the medical school, the dental school, it's a little more of an enriched environment because students are working literally all over campus. And I think, and another important aspect that I think I want to stress is that our goal in our program is to help you become what you want to be. Our goal is to train you how to think in the field of bioengineering and help you succeed in where you want to go. And so we stress that throughout your whole time here is we're trying to help you become what you want to be and through the lens of becoming a bioengineer. So I think that's a very important thing that we like to stress with our students is we're training you and helping you become what you want to be and not become what your advisor wants you to be. So I get that. I'll stop from there and we can have questions later if folks want.
Actually, Dr. Cohen, I did receive a question privately that I think you might be able to answer. And this is something that a lot of people may have on their mind. So if they've submitted an application to the doctoral program, could you, one, tell us when could they generally expect to receive a decision? And then two, can you tell us what is your procedure for evaluating an applicant? Like, are there interviews? Are there rotations? What is considered?
Right. So we have a slightly different format than perhaps other programs at in the engineering school. So we do what we call a match program. So what that means is that you submit an application and you express interest in a particular faculty, and then faculty are given access to the to your application. And then if a faculty member is interested in you and you're interested in them, that's part of the interview process. And what we do is we accept folks not into you're accepted to the program, of course, but you're also accepted into a particular person's 1 or 2 folks' labs. And when you come here, you then do rotations. So it's a match program where you're coming in, you're already matched up with a faculty member. However, given that, it's important to emphasize if you come and you meet the faculty member during the interview process, I encourage you also to talk with students in the lab. But it's important to note is that when you come in and you spend some time in the lab and you realize this isn't a good fit for a variety of reasons, you have the opportunity to leave the lab. You're not trapped in the lab, right? We're never gonna have you in a situation where you don't like. So we do a matching program. Typically we have 3 interview dates. So there are a couple in February and 1 in March. And so that's how the program works. So it's very important in your application is to talk specifically about specific faculty whose work you're interested in. You can never go bad by flattering faculty. So make sure that you're very explicit about a particular faculty who you're interested in. So I hope that answers that question. So Dylan asked in the chat, is it possibly a joint member of 2 labs? Yeah, I think many people are, you know, and how formal that is depends on the student, depends on the faculty. But usually students are co-mentored in a variety of ways. For example, my graduate students now are co-mentored by me, and I do more experimental work along with a physicist who does more sort of theoretical work. So there could be all sorts of things. Perhaps your lab is a little more translational. So then there might be different aspects where it's a more sort of basic science lab and a more sort of clinical lab. But yeah, that's very common. And we encourage that to build up your network, to build up your professional skills, and to give you as much access as possible. Let's see. There's a question about bioengineering. If you apply to a particular department, a particular program, only those folks in the program will look at your application. However, faculty can be part of multiple graduate programs. But if you're interested, for example, in working with me, and I'm not part of the mechanical engineering graduate program, so I would never see your application. So you have to apply to the program of the faculty member.
If I could just jump in, I saw a question about applications, and I can answer questions about the application process in regards to what materials you should submit. So if you have submitted 3 people to write you letters of recommendation, remember that only 2 are required. At this point, if you have 2 people who have submitted 2 letters of recommendation, then your application is considered complete in regards to letters of recommendation. So that's in reference to the question I received from Nusufar. I'm sorry if I'm butchering your name, but I hope that answers your question. I'm going to move us forward because we do have Dr. Lukes, and she's going to speak with us about mechanical engineering and applied mechanics. Dr. Lukes, let me know if you want me to pull up your slides, or should I give you access?
Can you give me access, please?
Yes, of course.
Okay, go. Okay, can all of you see my screen? Yeah, thumbs up if you can. Good, thank you very much. So I'm really happy to be here, and I'm glad to see that there's over 370 participants coming to this meeting. So you're learning about bioengineering and also mechanical engineering and applied mechanics. So my name is Jennifer Lucas, and I am the graduate group chair in mechanical engineering and applied mechanics, and we also call it the associate chair for graduate affairs. And so I want to give you some information about our graduate program. And so, this was a very important point that Professor Cohen brought up, is this concept of the graduate group. And so just to reiterate what he said, the graduate group is a group of faculty that is campus-wide that is focused on a particular area of inquiry. So for the mechanical engineering and applied mechanics group, these are faculty who do research that are associated with some aspect of mechanics or mechanical engineering. And those people can be housed in many different departments. And so, half of our graduate group faculty are in mechanical engineering, and the other half actually come from other departments across campus. So we have people from bioengineering, from earth and environmental science is where their primary appointment is. People from orthopedic surgery, physical medicine and rehabilitation, material science and engineering, electrical and systems engineering, physiology, computer and information science, and chemical and biomolecular engineering. So we have people from all sorts of disciplines that are involved in mechanical engineering related research, but who are housed in different departments. And so this is a really nice thing because it brings a lot of interdisciplinary flavor. And that's sort of the whole reason why Penn has this graduate group structure. And so what that means is that all graduate degrees are awarded by the graduate group and not by the departments. And that's different from the undergraduate degrees. And so that's a distinctive feature of our graduate programs. So just to give you a sense of the mechanical engineering and applied mechanics, we call it MEME. So if you hear me saying MEME, that's just what I mean. So we have about 85 PhD students in our program, and we've got around 134, maybe 130-ish master's students in our master's program in mechanical engineering and applied mechanics. And so we also have other students in other master's programs that have connections to mechanical engineering, but that are separate graduate programs. And so we have a master's in robotics. This is the Robo Masters. We also have a master's in integrated product design. And so many of those students interact a lot with mechanical engineering people who have applied and who have been accepted and are enrolled in the mechanical engineering master's program as well. And so you will have the opportunity to meet more than just this, if you're in the master's program, to meet more than just the 134 students. And so, so I'll tell you a bit about the PhD program. In the PhD program, our students take the median time to complete the PhD degree is about 5 years. And we have a 10-course, program where there's a certain number of core courses, a certain number of math courses, and then other elective courses that you take. And there's other types of training that you get as a PhD student. You have to learn how to conduct research safely, and so that there's a responsible conduct of research training, also laboratory safety. We have a teaching practicum where the PhD students actually are involved in helping be teaching assistants for some of the courses, and who are sort of educated on pedagogical practices. We have a seminar requirement. And so all of our students, we want our students to not just only focus on the very specific discipline and research that they're doing, but to be exposed to a broader range of research of different engineering flavors. And so, so the students will attend seminars, weekly seminars, where we have speakers come in from various areas. And so we have various different types of examinations in our program. There is, that's part of it. But the key part of this is that the PhD is fundamentally different from the undergraduate degree. It is fundamentally a research-based degree where you are creating new knowledge. And so, so that's the sort of key distinction, for example, between even our master's program and our PhD program. So the research is central to the PhD program. And so in our program, our students, when they're admitted to the program, they're funded, they're fully supported for the duration of their PhD studies. And so it is different from some fields. The engineers are covered full boat. And so that's a very important thing to know. So we have different research areas in mechanical engineering and applied mechanics. And so we typically sort of divide them into sort of 4 thematic areas. And so one of the areas is in fluid mechanics. And so in fluid mechanics, we study the flow of fluids at very small scales, at very large scales. And so, for example, looking at fluid flow in, microfluidic chips is one aspect of research. And so these are some microfluidic devices. The flow of sort of complex living and active matter. Looking at issues like turbulent flows and sort of tracking turbulent flows and tracking pollutant transport and tracking other types of things in oceanic flows. And so there's all sorts of research on how do fluids move and how can we understand what's going on with fluids. And so we have faculty working in various areas. So I'm showing some of the faculty who are doing research in the area of fluid mechanics. And so I don't think that I will read everybody's name, but we have several faculty who are involved in different aspects of fluid mechanics research. And so, so what I'd like to do is give just a couple of specific vignettes on some of our younger faculty so that you can get a sense of some of the newest research that's going on in our program. And so, so just to give a couple of examples, so we have 2 of our junior faculty in fluid mechanics. And so, so on the left, we have a Professor Perdikaris, and his area of research is related to machine learning and sort of combining different types of models at different levels, physical models, machine learning, and sort of integrating them together to do all sorts of, to pull all sorts of interesting and useful information relating to fluid flows. So like, for example, this picture, they're trying to run some sort of cells through some sort of diagnostic device. And so they're doing some imaging at this particular cross-section of the device. And by doing some analysis of the images that are being shown in this particular region right here, he can do like really rapid diagnostics using machine learning to identify cells that are healthy, cells that are sick, and but he's doing a lot of interesting work combining fluid mechanics and machine learning. And so another one of our junior faculty in the fluids area is George Park, and Professor Park is working on areas related to turbulence. And so, how do you make airplanes fly better? And so one of the key aspects of these sort of high Reynolds number flows, or these sort of flows at high speeds, is, understanding how does the fluid flow over the wing? How do you avoid issues like separation? How do you control the aircraft better? And so he does a lot of very complicated and involved modeling of how the fluids flow over the aircraft wing. And so he works on developing better models, computer models for how the wall interacts with the fluid. And so we also have a second area of research, which is research into thermal and energy sciences. And so the faculty who are involved in this area are shown below. And so this is, I'm one of the faculty in this area, but we also have several others who are doing thermal and energy related research. And so just to show, a couple of snapshots of some of the things that people are doing, people are developing better types of devices to harvest waste heat and turn it into useful electricity. And so, for example, in automotive systems, you put a gallon of gas in the car, and only about 25% to 30% of that gallon of gas moves the car forward. And so all the rest of it is wasted, in friction and in heat. And so if you can capture that heat energy, you can make a more efficient car. And so, there's all sorts of different research related to harvesting thermal energy. And so Professor Bargaton has worked, on some of these thermionic emitters. And this is a way to capture electrons emitted from hot surfaces and convert that into electric currents and power. And so we have, other work related to battery research. So Dr. Pikul, he's one of our faculty who works on developing better batteries and better electrochemical energy devices. And so just focusing in a little bit more on that. So again, focusing on the micro batteries, so one of the research areas that he's working on is developing better battery architectures, because one of the key challenges in batteries is they overheat and they set on fire. And so and batteries are incredibly important for thermal energy storage. And so how do you actually develop batteries that don't overheat? If you have a nice interconnected material that can actually sink the heat out faster and keep the batteries cool so that they can actually operate effectively. And so this is some of the work that he's done on this. He has other research into other types of energy systems. And so we also have Professor Bargaton, and so he works also in the area of micro nano energy conversion devices. And so he actually uses the same center, so that center that was shown before, to build these nano fabricated devices for not only for harvesting energy, so for these thermionic emitters, which are capturing hot electrons and converting them into current, there's a lot of sort of specialized architecture that you have to build at really small scale. So you can't go in the machine shop. You actually have to go into, the Sing Center that Christina had mentioned earlier. So you can make the really tiny stuff. And so these are some of the examples of some of the devices that he has been able to make. So our third area of research in mechanical engineering and applied mechanics, we sort of group this into mechanical systems and robotics. And so also controls, falls under this as well, typically. And so in the GRASP lab, so if, many of you may be interested in robotics. And so the GRASP lab is sort of this preeminent robotics research laboratory that's very famous. And they make all kinds of robots. And it's a really nice center that combines mechanical engineering, computer science, electrical and systems engineering. There's all sorts of different departments and graduate groups involved in work in the GRASP lab. But they make robots, so there's different kinds of robots. I've shown some pictures. There's tiny robots, there's robots that walk, there's robots that swim, there's robots that fly. And so these are, some of our faculty in the MEAN graduate group who are working on robotics related research. And so, so I won't name all of them, but just to give you, again, a couple of vignettes, a couple of snapshots of some of the work done by our junior faculty. So on the left here, so we have Professor Sung, and she works on this really cool idea of origami-based robots. And so it's so interesting, if you if you fold the origami correctly, for example, if you need to do a search and rescue mission and you have a robot and the robot can't fit through this tiny crevice, to get through the rubble to to sort of get some sort of get to and survey a disaster area, for example. What if the robot could fold? And so if you can have a robot and it folds down when it needs to, and then it opens back up, you can actually access and have much more functionality. So she works on designing different kinds of systems that that fold, that unfold, and that can deploy. You can increase your area and reduce it by using a lot of very interesting combinations of geometry and robotics. And so another one of our faculty, Michael Poza. So Professor Poza, what he works on is understanding more about how robots contact the surfaces that they interact with, because the contact problem is quite challenging. And so if you have surfaces and you're not correctly accounting for how the robot interacts with the surface, that can cause a lot of challenges. If you have a slippery surface, if you have a grippy surface. And so he works on a lot about contact-rich control and planning for robotic walking. And so this is his area of research. And so our last area that we cover in mechanical engineering and applied mechanics in our program is research and mechanics of materials. And so this is, how do materials respond to loads, to stresses? How do they deform? How do they move? How can you engineer new types of materials and interfaces between materials to achieve functions that you are interested in? And so, this can encompass things, related to, for example, composite materials, materials that have grains, interfaces in between materials, the friction of, between materials. If you have composite materials under load, how do they behave? And so we have, a large number of faculty who are working in this area as well. And so to just give you, so here I have 4 snapshots, and actually only one of these faculty is a junior faculty. So I'll talk about him first. So Professor Jordan Rainey, he works on architected materials, and so he's very interested in creating taking the structure of materials, and instead of just having a material that is a solid chunk, he'll engineer patterns and structures in order to get it to, propagate waves in desired ways. So for example, impact resistant materials or materials that have very interesting wave propagation functionalities. And so he uses a lot of 3D printing and engineering of these 3D printed structures to architect or to build the structure of materials that have all sorts of interesting mechanical properties. So to highlight a little bit the connection that we have to, to the medical school. So one of our graduate group members is Yale Goldman, and his area of research is actually understanding, how do microtubules walk, and how do you have these molecular motors? And so this has impact in all sorts of diseases, muscular dystrophy and other types of things. And so he does a lot of, very interesting work trying to understand basic mechanics and the connection between mechanics and biology. And so studying, how these molecular motors work. So we also have research in nanotribology. Tribology is the study of friction and wear. And so Professor Karpik looks at this on microscopic scales at the nanoscale. And then we also have Professor Kevin Turner. And so he's very interested in understanding interfaces, how the mechanics of interfaces work. And so he does various things to study the adhesion properties in various types of materials. Okay, so I'm done talking about the research. So again, Christina earlier had showed you about the Singh Center, and so these are some images of the Singh Center, some of the things that you can make. We have the Ad Lab, which is another facility that is in mechanical engineering. So this is our additive manufacturing lab. I believe we have, I think, 2 or 3 3D printers in there now. We also have the DML, which is, I'm forgetting what the acronym stands for, but it's PML, it's the Precision Manufacturing Laboratory. And so this is our machine shop, and we have a very, well-organized staff who can help in any of the construction of any experimental equipment that you might need. Pennovation, Christina had already spoken about. And so, what happens when you graduate from our program? So for our PhD students, they go to many of these institutions here, many of these universities that are shown. I'm not going to read all of them. our master's students as well. You know, I haven't spoken much about the master's programs, but just like in BE, we also have specialization. So when you get your master's degree from our program, you can have a master's degree with a concentration in mechanical engineering and biology and medicine, specialization in thermal fluids, energy engineering, specialization in robotics. And so when you're in the master's program, you also have the ability to just sort of focus in these various concentration areas. And so, you know, our master's graduates from our program go to all sorts of places as well. And so, so they go to many of these places. We've had some at SpaceX, for example, and various other types of places that are shown here. And so, so one thing I want to point out that we haven't talked much about, and maybe this is for later, but what I wanted to say is that it's really, really important, you know, when you come to the program to connect to the graduate student organization. So I think when I was a PhD student, I think one of the important things that helped me get through all of the struggles, because a PhD is a struggle, like there's a lot of challenges in getting a PhD, and you should be aware of that, but like having a strong sort of graduate student organizations, connecting with MEGA. So MEGA is Mechanical Engineering Graduate Association. They're really, like, I think, a really important part of our program, and sort of building those connections with the students. We have different social events, different career development events and things that happen. And then engineering-wide, we have GSEG and we have GAPSA, which is Penn-wide. And so these are different levels of organizations for graduate students. So of course, look at our website if you've already applied to our programs, or if you're aware of this information session, you probably already looked at our website, but there's a lot more information that I haven't been able to share today. So I'm going to close here. So what I'll say is, for our mechanical engineering and applied mechanics program, you know, if you're interested, you know, in our PhD program, I'm the person that you can contact in terms of if you have questions, like specific, like research related questions and other things. If you have general program questions, the best person to contact is Mary Eileen Griffith. She's the Associate Director of Graduate Programs. She knows everything about the master's program, the PhD program. And the person whose name I didn't put on here is Professor Howard Hu, and he directs our master's program in mechanical engineering and applied mechanics. And so if you have questions that are specific to the master's program, you can contact Professor Hu, or also you can contact Peter Litt, who is the coordinator for the master's program. So I really want to thank you for your attention. I'm so glad to see so much interest in our information session tonight. And so thank you.
Thank you, Dr. Lucas. I appreciate that thorough presentation. And I'm glad I have those slides because I may use them again. So thank you very much. I do have two questions for you. Our next process is to go into the student panel, but before doing so, I had two really good questions regarding meme that I'd like to bring up. Let me just find them here in the chat. I thought you would be the best person to answer them. Okay, so the first one was from Alec. And he said, in the master's meme handbook, it says that most master students complete a coursework master's and only top students do the thesis option. Do most master students do the coursework option by choice or as a result of constraints such as funding and availability of advisors?
Right. So in order to do a thesis, so you have to, so a thesis obviously is not something that one can do in isolation. And so if you are interested in doing a thesis, you know, what you need to do is you need to contact a faculty member who would be a potential thesis advisor. And so we definitely do have master students who do thesis research. But if you want to do research, you know, on a topic that like nobody is doing research in, it's going to be hard for you to do a master's in our program because you won't have like the people who can advise you on that project. But certainly the best way to begin is, you know, you apply to the program, you show up, and then in your first semester, or even beforehand, right, you sort of make contacts with faculty who you think you might want to do research with. And so there is not, there is no limitation, you know, in terms of, you know, you just have to find a sync or a match with a faculty member who wants to advise your thesis project.
All right, great. We do have another one from Aaron that says, does the Department of Meme also follow the 2 interview sessions, one in February and one in March? I'm assuming that's for PhD applicants.
2 interview sessions. So we have a fall information session that we do, and we have for the admitted PhD students, we have a spring information session as well. So I think that I'm hoping I'm answering the question that was asked, but we do have informational sessions in the fall and the spring.
Thank you, Dr. Lucas. I think the person was just comparing the process for bioengineering with mechanical engineering.
Okay.
But that's helpful. And then one more question before we open it up to the student panel. I have a question that says, Dr. Lucas, is there frequent collaboration of UPenn Meme labs with federal research centers like NASA?
Yeah, so that is possible. So I know we have, I don't know that there's a current NASA connection, but for many years, one of our former faculty, Professor Ayaswamy, who recently retired, he had longstanding collaborations with NASA. So like and actually I think Professor Park might have some NASA related research as well. I believe he has a new project that has some, I believe it's a NASA connection. And so really, so there certainly are connections between different, like federal research laboratories. It's really like dependent on the advisor and sort of the time, but we definitely do, there are collaborations. I believe I believe that that our Professor Shesh, that she has some connection to the Naval Research Laboratory. So there are different types of connections to other types of federally funded labs.
All right, great, thank you. So I just want to take us back to our schedule and give us plenty of time to interact with our current master's and PhD students who are on this call. So I'm going to ask them to step forward. We definitely have 6 people from the mechanical engineering as well as the bioengineering program. So I'm going to ask each of you if you can just unmute yourself one at a time, tell us your name, where you're from, your current learning location, so whether you're actually in the city of Philadelphia or elsewhere, and tell us which degree you're pursuing, since we have both master's and doctoral students represented.
So hi everyone, my name is Daira Deitu. I'm a master's student in the dual master's program or dual degree program. I'm studying bioengineering and mechanical engineering, and I'm currently taking classes from Maryland.
Hi, my name is Shiping, and I'm studying mechanical engineering and as well as computer and information technology right now. And I'm currently in Philadelphia.
Hey everyone, my name is Placid. I grew up in Nigeria and was raised in Texas. I'm currently in Philadelphia right now, and I'm the BE PhD program, but previously I was also in the master's program.
Hello. Hey everybody, you can go.
Oh, I didn't know if there was like a list of people or if we're just randomly jumping in. But yeah, I guess I'll go. Hi, my name is Tala. I'm from Beirut, Lebanon. I am doing the master's in bioengineering. I'm a second year master's student now. And I'm currently in Philadelphia.
Okay, I can go. My name is Samto. I was born in DC, but I grew up in Nigeria as well. I'm in Austin, Texas, and I got my master's in bioengineering.
Hello everyone, my name is Rasim Boshajor. I'm in the PhD program in Rainey. Born in Haiti, grew up mostly in Delaware, and I'm currently in Philadelphia.
All right, great. Are those all of the Penn Engineering graduate students on the call right now?
I think there's one more, but maybe we should, she's just getting on now. I guess more than one.
Hi, my name is Miao. I'm from China. I'm currently located in Boston. Um, I graduated with a master degree in a mechanical engineer with a concentration of dynamic system controls last year. I applied for the PhD in MEM. Oh, Boston.
All right, thank you. So these questions are specifically for our current Penn Engineering Masters and PhD students on the call. Thank you so much for being here with us. As you see, we have a lot of people who are eager to learn more about our graduate programs, and you are the best resource for helping them to see what Penn Engineering has to offer and sharing a little bit about your experience that might illuminate for them, which programs are appropriate for them. So I'd like to ask the second question here. What factors led to you applying to Penn? What about your experience with your advisor, instructors, or staff at Penn Engineering made you decide to attend? So I know prior to COVID, a lot of people or prior to the quarantine, a lot of our current students had the opportunities of coming on campus and doing some of our on-campus recruitment events. So tell us about why you applied and what made you choose Penn.
I could start. Once again, my name is Rainey. I worked in industry for a few years in defense contracting. And one of the reasons I chose Penn was definitely the resources. And by resources, I mean all the facilities and professors that they have. So I currently work in the Singh Center, which has a very nice fabrication lab. And some of the professors as well are known worldwide. And so the resources there is none like you'll get anywhere else, as you mentioned before. So that's one of the decisions that led me at Penn, the phenomenal resources.
I can go next.
Okay. You can
Is
go.
it okay? Thank you. So what led me to transition from the master's program to the PhD program was the personality of the people I was working with. My advisors were very nice and encouraging. And I remember at the end of my master's program, I wanted to go to the industry, but then my advisor was like, no, you should pursue a PhD. You'd be a great PhD student. And he was like, I never even thought of you as a master's student this whole time. So that was very encouraging. And the research was the second thing. I was really interested in working on neuromodulation devices and being able to once again use my electrical engineering skills that I had in undergrad and translated it into BE, into bioengineering applications was also another selling point.
Yeah, kind of in similar vein. I was kind of attracted to the bioengineering program because of how strong it was. For full disclosure, I applied to Penn as a freshman right out of high school. But I decided to stay and apply for the master's program and submatriculate into the 4+1 program that we have here, because I knew that they would, the one aspect was that the people and the culture was really strong. I saw people that I could easily identify with thriving and doing well. So that was a positive indicator for me. But also I saw that I could pursue my interest in medical devices and entrepreneurship. There are a lot of ancillary factors for the bioengineering department that help kind of pursue, students pursue their interests. One of that would be the Penn Center for Innovation. Students can go there and pitch ideas to the administration there, and they'll help develop your ideas and bring it to fruition and try to help you commercialize your ideas. Another space that encouraged me to stay for the master's program, it was the biomaker space, which is basically an innovation hub within the bioengineering space. Students can go there and work on their rapid prototypes, and there's free printing there, and a lot of students just congregate just to teach each other things about data acquisition. So that's a very strong point of the bioengineering department. So in summary, I stayed because I knew that the department could foster my interest in entrepreneurship and also biomedical devices.
I can go next. So just to introduce myself, my name is Serena. I'm a first year PhD student in bioengineering. I'm also from Lagos, Nigeria, so I'm an international student. And the main thing that made me choose Penn, I think, was the breadth of research that was available. So the way the bioengineering department is set up is, you have a graduate group where basically if you're a grad student, you can work with professors from different departments like pharmacology, etc. So that was very appealing to me because that meant I had so many professors whose research interest was similar to mine. So there were many things I felt like I could be interested in, or many labs I felt like I could work in. So that was the main factor for me.
I can go next. I got my bachelor's in chemical engineering at Georgia Tech, and I guess why I decided to get my master's at Penn was really, I guess, similar to what Daya said about how good like medical devices and how entrepreneurship works at Penn. I think that really attracted me to Penn also because it's linked to the hospital hub. I thought it would be interesting to kind of, I guess, carry on my master's in a program that was so closely linked to the hospital. I thought that would kind of give me some exposure to like clinical uses, I guess, of the things that we would like learn in class. So give us an opportunity to actually go into clinical settings and like talk to people. And I say, I mean, my reason isn't that serious, so I chose Penn exactly. My dad toured the campus for me because I couldn't. And he spoke to one of the graduate advisors, I think it was Kathleen, and he was like, she was really nice, the campus was really beautiful. So I was like, I mean, that's good enough for me, I guess. And the program was ranked highly, so I was like, sure, that's good enough.
Oh, yeah, I'll go next. Yeah, so I originally applied because I was really attracted to the interdisciplinary work here. And I think there's a lot of innovation here as well. And as well as technology and talking to advisors. And I did find collaboration very important. And I think Penn does a good job of really helping people if you actually voice your opinions. And I think trying not to be afraid of voicing opinions is important, and seeing other people being themselves and actually striving, I think it's really encouraging.
All right, thank you, Penn students. I do have other questions, but I think that I'm going to interrupt my question for a great question from the audience. So I have a question from Aaron that says, are any of the current students here planning on pursuing academia post-graduation? If so, how has Penn prepared you for this? So I'm assuming, Aaron, you're talking about our PhD students who are on the call. So PhD students, could you answer that question if you could for us?
Penn definitely prepares you to pursue a career in academia. There's various resources that's available, like the Center for Teaching and Learning. A lot of the programs also have teaching practicums where you TA several classes, where you get a chance to teach students as well. And so there's various opportunities, various resources that allows you to learn the skills that you need to become a great professor. The Center for Teaching and Learning, they throw various events from how to use technology in the classroom, how to engage students, various things like that. So like I mentioned before, the resources here, anything that you want, you could find here. And so definitely there's a lot of resources.
Yeah, like Yale said earlier, that your advisors are here to help you become who you want to be. And even if your advisor may not have the necessary skills related to your research, they can connect you with people who does. And as far as like, there's the TA, you can be a TA, you can also join like different organizations if you're into entrepreneurship. So I think there's a lot of resources out there just to, truly help you become who you want to be. I think the hard question is like, who do you want to be, and like what kind of, you want to go into industry, do you want to go into academia? There's a lot of resources out there to like help you in either path.
All right, thank you. I'm going to move us on because we do have other questions, and we have a lot of really eager attendees who want to hear from current students. So I'm just going to pose this question, and I'll start taking some questions from the chat. But what are the most difficult aspects of transitioning? So either from an undergraduate program to a master's program, or from an undergraduate program or from a master's program to a PhD one. And in those transitions, how did you overcome them? What did you find helpful?
I can start that. So I don't know if I mentioned this earlier, but then I came straight to the PhD program from an undergrad program. So I can speak from that perspective. So I think for me, it was transitioning from kind of having more steady support to being more fully independent. Like being in your own lab, kind of being expected to, have your own project, have your own timeline, which was kind of different from undergrad, where you kind of have more railings to guide you. And I think for me, what's helped a lot is talking to a lot of the for example, the graduate group chair at Yale, or talking to different advisors, or even other grad students who have been through the same thing. Like it helps just getting their advice, getting their perspectives on how to handle things. And I think it goes a long way too, especially learning how to navigate new situations, like for example, coming into a new PhD program, hearing from people who are more experienced and people who've gone through this before. I think that was something for me that really helped a lot.
I can also answer that. I got my bachelor's in chemical engineering, and I straight away went to get my master's in BE, which are two separate fields. And the BE program at Penn, I was more so interested in BE as it relates to was BE and meme kind of. I would take classes that were kind of BE and meme. I didn't have any experiences with coding or with electrical stuff. And I think what helped me, I guess, navigating that transition was talking to my professors, like the classes I took, to just kind of let them know like where I was coming from, and to see if there was any support that I could get to kind of, I guess, catch up and learn things that I didn't. And I know that I already mentioned it, but BE has like a makerspace, an educational lab. I worked there while I was getting my master's, and on the website, there's like a tutorial and link section that kind of has tutorials and a lot of things that I guess you need, whether it's like wet lab work or whether it was like electrical or like mechanical stuff. That was really helpful for me to talk to people and talk to other students, to find out other people who I guess had similar transitions to me, to kind of learn how they navigated it and figure it out myself. It was also really helpful to meet people. That also kind of helped me to talk to other students, to kind of find myself with other people who were kind of going through the whole process of transitioning from getting a bachelor's degree to doing a master's, to just be like, okay, I'm not alone, I'm not the only one who's freaking out. That was helpful.
So kind of in the same vein of what Somto was saying, I found that whenever I have difficulty really engaging with the community that I have helps to counter that. And also I think the challenge for me came from, I was trying to seek opportunities for like professional pursuits, but I wasn't exactly well-versed in how to do that. So really challenging myself to push myself, and, you know, like the master's, for at least for me, is like the last stop. So I had to exactly figure out exactly what I wanted to do and like concentrate on exactly what my professional pursuit was. But one thing that's helped me is that this year and last year, I become really involved with the Graduate Association of Bioengineers and also the Mechanical Engineering Graduate Association. So those are our graduate associations. And I found that the culture within these groups is really welcoming. People will go out of their way to support you. Right now within the Graduate Association of Bioengineers, we have like a fitness challenge, which involves like faculty and students. And I found that the faculty are like really competitive. So it's really nice to just see that aspect of like the faculty, like not in an academic sense. And I think that it really helps to foster like organic connections with people. So the academic component is one portion of your journey at Penn, but really making sure that you're seeking opportunities, engaging with the community would make it a lot, I think, more fruitful. So I would just advise you guys to reach out to people, even if it's a little bit daunting at first, just like make sure you're trying to foster those connections.
Thank you. I think your responses spoke to people's question about the culture within your departments. And I think that you demonstrated in your responses that it can be daunting to connect because we're seen as we are such a huge university, and you know, it can be intimidating to reach out to new people, but when you do so, it's worth it. And when you do so, there is a welcoming community. That's what I'm getting from the students' response. So I appreciate that. There was also a question regarding internships. So could you think about current students, your external learning opportunities while a graduate student, and tell us how you acquired it and, you know, what experiences you've had, maybe as a teaching assistant, maybe you've been an intern externally outside of the university. Could you talk about that and how you acquired those experiences?
So I personally have not interned, but I know many PhD students who have, and it's really dependent on what research you're pursuing and the relationship with your advisor. And so there's some students who got an opportunity to intern at some national labs, which corresponds very well to their research. So that went well. So that goes very well. There's other students who work or do internships maybe the year before they graduate, so that way they could start that networking opportunity. But there's a lot of career opportunities through Penn in the career services. And so, but the most important thing is making sure you have, you communicate with your advisor and you let your advisor know that's definitely something that you want and experience that you want, and you coordinate that ahead of time.
I say also in BE, whenever there's like TA opportunities or opportunities to work for professors, they send out emails usually to the BE, MS, and PhD list, kind of telling you what the professor is looking for, what the job is. And I worked at the biomaker space, the educational lab. And that's how I got that job. I didn't intern, but I also got a full-time job towards the end of my master's program as well. And that was through Handshake and going to the career fair that Penn has. You know, you go to the career fair, there's also Handshake, you sign up for that. You can, I guess, like companies they're interested in, so that whenever they post new jobs, you get an email immediately to kind of see what's going on with the companies they're interested in. Yeah.
All right, thank you. I guess I have two more questions, just reading through what everyone has said. Thinking about what we're in now, almost a year of being in pandemic. So tell us what it's been like for you to maintain communication and research with your advisor during this time.
Penn has Blue Jeans, Zoom. Those resources are free for graduate students. So when the pandemic first hit, a lot of students met with their advisor via Zoom. And I think most people are still meeting with their advisor via Zoom and having group meetings via Zoom. And so, resources or the campus is available on a limited capacity to some people. I do research at the Sing Center, and that's currently where I'm at now. And so there's various protocols, and I feel very safe as I'm here on campus, following all the protocols for COVID. And so, but that's just my personal experience. In regards to doing research on campus and communication with your advisor, it's really on a person by person basis. And for students who are doing research on campus, and I'm of course speaking from the PhD student perspective, it's a opt-in process for research on campus. So if you're not forced to go out and do research on campus, if you're not comfortable with being on campus. So I definitely appreciated that. But I hope that kind of answers the question.
All right, thank you. So my last question for the panel is just thinking about, we have people on this call right now who have applied to either the master's or the PhD program, who maybe have received a decision or who are awaiting a decision. And I hope that you can just think about what it was like for you when you were in their position, and what could you advise them about how to figure out their next steps. So maybe somebody has applied to the master's program, but in speaking to some of you all is thinking, well, maybe I'll go on to pursue a PhD. Or maybe someone is looking to apply to the PhD program and is not sure if they want to go into academia or industry. So what advice could you offer based on the experiences you've had?
So I would just offer, when in doubt, always reach out to people who you think could offer some advice. I've often tried to figure out my problems in isolation, and I've found that reaching out to people is definitely the best option to do so. If you need help, I would recommend reaching out to the Graduate Association of Bioengineers. We have a full recruitment team that helps people along their process, and will gladly answer any questions if you have any. MEGA, the Mechanical Engineering Graduate Association as well, also has some recruitment initiatives. So I would definitely make sure to Google the website, Google these associations, just so you're aware of the current programs that are going on.
I think for me, you need to try being a TA, because it's not mandatory to get an idea if you want to be a professor. I know when I TA'd, that was for me. I was like, maybe academia wasn't necessary for me, and you need to try writing grants, and your advisor, at least my advisor, always encourages me to be part of the grant writing process. So going through what a PI would do, going through that process with your advisor is very helpful to decide between academia and industry. And internships too. My advisor encourages me to apply for internships if I want that experience. And I would say just try everything out. Try the academia route, and try both the industry route.
My advice would be to, most people here are either trying to pursue a master's or a PhD. And I think that's a great thing. A master's or PhD definitely opens the door to many opportunities. If you're considering pursuing a PhD, I think as Dr. Lucas mentioned, a PhD is a very in-depth research. And if if you don't like research, then maybe a PhD is not something that you should be considering. But also understand that the goal is new discovery as well. And so if you know that you're either interested in being in academia or you want to perform research at a high level, even in industry, then maybe a PhD is something that you want to consider. My recommendation is also always talking to a mentor. The best way to figure out if you want to do something is by talking to somebody who has already done it. And so talk to as many people through various experience, various types of PhD, and see what kind of experience they had. What are the benefits? What are the negative experiences? So that way you are fully aware of kind of what you're getting into. And then understand that you have the summer, and just if you apply or you don't get in this time around, there's also, you just continue applying, and there's always the next round as well. If it's something that you really want to do, don't stop pursuing it. And yeah.
I think for me, my biggest piece of advice would be to do what you're passionate about, especially when it comes to choosing a research field. Because for me personally, I don't think I really understood the magnitude of that until after I applied. But I would say that if you do decide that research is for you, if you're choosing a field, make sure it's something you can see yourself doing for the next maybe 4, 5, 6 years, because that's really what keeps you going, even during times when things are difficult. And as people have said, talking to people, like forums like these are really great ways for you to gauge what you might like. You know, talking to graduate students in research labs that you might be interested in will help you really tell if this kind of research is something that you would enjoy or something that you would like doing.
Yeah, I mean, I just want to follow what Serena said. You got to find what you're passionate about. That's really it. I mean, let's put it this way. Grad school sucks unless in general, and the only way to make it a really great experience is when is the research you're doing, you're passionate about, right? That'll keep you going for the 5 years. If you're not passionate about it, it's not the place. It's not the lab. So you really got to find what makes you passionate.
I think that's an excellent note to end our panel on. Thank you, Dr. Cohen, and thank you all of our current students. I'm really thankful that you spent your time with us today. And I'm just based on your advice, I'm going to ask everyone to direct any further questions either to Dr. Cohen or Dr. Lucas, or you can also contact one of the graduate associations for students through those different departments. So thank you guys for being here. And I'm just going to close out. I just have a little bit more information to share with you if you want to stay connected with graduate admissions. We will be conducting other recruitment events such as this one, maybe one where we give a little more time for just students to talk with prospective students, because it seems like you guys have excellent questions that could be really useful as you think about your next steps. So stay connected with us. You see here, Graduate Admissions has Facebook, Twitter. This session actually is being recorded and it will be posted to our YouTube channel. So make sure that you follow us at Penn Engineering Graduate Admissions. And if you want to request more information, for example, if one of the graduate programs you're interested in, their application closed for this season, you can definitely request more information so that you're prepared when the application opens again in September. So that's it for us. Thank you so much for being here. And we look forward to you hopefully joining us again, either in another session like this or on campus one day. So thanks a lot, everybody. Take care.